All right, here's your guys' notes on end behaviors of polynomial functions. So students will be able to identify the end behaviors of polynomial functions. So polynomials are characterized by their degree, you guys, and the highest exponent, which is the highest exponent or power of your x variables. So right here, you guys, here are degrees and here are the names. Now, if the highest degree is 0, this is what a constant graph could look like. If the highest degree of your polynomial is 1, this is the graph of a linear function. 2, quadratic, 3, cubic, and so on. So these are just representations of what your guys' graphs could look like for each type of degree. Okay? So the end behavior of a polynomial function depends on its degree and the sign of its leading coefficient. This is called the leading coefficient test. So in order to determine the end behavior, one way you guys can do it is looking at the degree of your polynomial and the sign of its leading coefficient. So the sign of the leading coefficient is always attached to your guys' highest degree. So here we have this. If you have an even degree and a positive leading coefficient, your end behavior is going to be left side up, right side up. If your degree is odd and it has a positive leading coefficient, it's down and then up for end behaviors. If your degree is even and your leading coefficient is negative, it's down, down, and odd degree, negative leading coefficient, up, down. So let me give you guys some examples for you guys to kind of just see, right? So let's take a look at something like this. The highest degree in this example, you guys, is 3. And the leading coefficient is 3. So this degree is odd and this coefficient is positive. So the end behavior of this graph, you guys, is going to be odd, positive. So your guys' end behavior is going to be down and then up. That's that graph right there. Let's take a look at another example. What if you guys had this one? Right? What is the highest degree? The highest degree is 2, and the leading coefficient is -4. So this degree, you guys, is even, and the leading coefficient is negative. So an even degree with a negative leading coefficient, you guys, so your end behavior is this one, down, down. Okay? So that's how you guys use the leading coefficient test. It helps you to determine your guys' end behavior. Okay, let me throw you guys a curveball. Okay, you guys look at this one. What is the highest degree? It is 11. What is the leading coefficient? Remember, the leading coefficient is attached to the highest degree, which is -7. And that makes sense, you guys, why that is the leading coefficient, because if you guys had to change this to standard form, right? Don't you guys put your guys' degrees in order from highest to lowest? Right? And look, the leading one would be that -7. So just remember, your leading coefficient is always attached to the highest degree. Now, let's look at what we have. Odd, and that's a negative. So if an odd degree and a negative leading coefficient, your end behavior, you guys, is that left-hand side up, right-hand side down. Look at this, right? So that's how you guys determine your guys' your end behavior, by using the leading coefficient test. So for these ones, you guys got to determine the degree, the leading coefficient, and your guys' end behavior for all 3 of these. The degree for A, you guys, is 10, and the leading coefficient is -20. So the degree is even, and the leading coefficient is negative, so even, but a negative leading coefficient, so that means our end behavior is down, down, just like that, right? Let's do the next one. The highest degree is 3. The leading coefficient is -1. And your guys' end behavior, well, the degree is odd, and the leading coefficient is negative. So odd degree, negative leading coefficient, right there. Your guys' end behavior is up, and then it's down. Okay, try this one. The highest degree is 8, and the leading coefficient is 8. So it's an even degree with a leading coefficient that's positive, so your guys' end behavior is left side up, right side up, up, up. Make sure to do your guys' scales from 1 through 5. Okay? Now, you do have to write this down. Okay? And yes, you should partition this or split this up as I do as well. Now, there is something called justifying your guys' end behavior answers. And you do that by this. So I suggest you all write this on your guys' graph, just like so. So it's going to take you a minute, but make sure you write all this down. So once you all write this down, pause the video so that you get all of this. And then when you're ready for, here, I'll just copy it all down first. So write this all down, you guys. Okay, so I'll write that all down and then let me explain this, okay? So you would all agree that going to the right, x values only go right and left, right? X values only go right to left, and f of x, which is y, you guys, that only goes up and down. So if you guys know x only goes right or left, as x approaches infinity, that means you are going to the right as x is going to infinity. So one way to describe as x is going to infinity, you guys, is as x is approaching to the right, or it's moving, or it's increasing. And x approaching negative infinity, you guys, that means you're looking at the left-hand side, or it's decreasing. So if you guys, as x approaching infinity, if you're going to the right, what is f of x doing? Or what is the direction that this arrow is moving? And as you guys can see, this arrow is going up. So f of x is approaching positive infinity, which means it's going up, which is true, right? As x is going to the right, so looking at the right arrow, you guys, that means your f of x is increasing, going up. Now let's take a look at the left-hand side though. If x is negative or approaching negative infinity, you guys, what is your left-hand behavior doing? It's also going up, and you guys describe that as positive infinity. So look at the right arrow, that is increasing upwards, so f of x approaches infinity. If you guys look leftward, which is as x approaches negative infinity, your left-hand behavior is going up, approaching positive infinity. So this does getting used to, and this is how you guys justify your guys' end behavior answers. So let's look at this one part, the next one. As x is approaching infinity, which means going to the right, look at this right arrow, right, you guys? As you're moving to the right, what is f of x doing? It's going up, which means it's approaching positive infinity. Now look, you guys, if x is approaching negative infinity, which means going to the left-hand side, so the left arrow, what's your arrow doing? It's going down. So that means f of x is approaching negative infinity. It goes negative downwards, right? So when f of x approaches negative infinity, that's going down. But this one, you guys, is going up. So it's all about knowing your guys' right and left-hand side and behaviors. Let's try the next one. Notice, you guys, this is written for every single one, right? It's just the f of x that changed. So as x approaches infinity, so that means going to the right, so looking at your guys' right arrow, what is f of x doing? It's going down, which means approaching negative infinity. If x approaches negative infinity, guys, which means going to the left, this arrow is going down. So f of x is also approaching negative infinity for this one as well. Right, left, down, down. Let's look at here. What is the right-hand side doing? As x approaches as x is approaching positive infinity, your guys' right-hand behavior is going down. So this should say negative infinity. If your guys are looking at the left-hand side, so as x approaching negative infinity, your arrow is going up. So on the left-hand side, the arrow is going up for positive infinity. So again, you guys need to know how to do that when you guys justify your guys' answers, okay? So hopefully this helps you guys with your homework. If you have this on your back, don't worry, you don't have to do this for today. So I cross that off. So this is your guys' notes on end behaviors. Good luck on your guys' homework assignment, and hopefully this helps you guys, okay? Adios. Peace.